today's podcast. Today with us, we have Marc Segura. Marc is Group Senior Vice President, Managing Director of Consumer Segments and Service Robotics at ABB, where he spent 20 plus years by now.
Yep.
Marc, welcome to the show.
Hi, Peter. Pleasure to be here.
Well, Marc, it's really nice to see you again. Of course, we know each other from Covariant ABB collaborations, and it's really nice to get to catch up here. Now, as a first thing, to set a little bit of context for our audience, could you maybe say a little bit about what is ABB? How big is it? What does it do?
Yeah, well, ABB is a technology and engineering company. It is the outcome of the merger in 1989 of two companies. That one was ASEA from Sweden, and the other one was Brown Boveri from Switzerland. They come both from late 19th century, so more than 100 years at the time of the merging. And they were really developing electromechanics at the beginning. So they were starting with electrical motors, which we still do today. There was a large part on power generation and transmission and distribution that, we spin off or we sold a couple of years ago. And throughout the century, we really were always striving to, based on electricity, I would say, develop the next new thing. Again, we put traction on trains. We put electric propulsion in big ships. We created the first computer-controlled electromechanic robot, and so on and so forth. So ABB today is a 30 billion plus company with a presence in more than 150 countries, with more than 110,000 employees. And that is working in 4 business areas: electrification, process industries, motion, and robotics.
Wow, and that's quite the history there. And of course, for me, the thing I've seen most from ABB is the robotics side of things, which is also the division you are in, right? Yeah. Can you say something about how many ABB robots are in the world right now?
Yeah, so ABB has delivered more than 500,000 robots in its history. Okay, and we believe, because that's difficult to track. I mean, robot life cycle in our case span from 12 to 15 years on average, but we have robots that have been working tirelessly for 30 years. So our good estimation is probably that there's really well beyond 150, close to 200,000 robots working out there still today.
Wow, that's amazing. And so when you think about these robots out there doing things, what are they doing?
Well, what our robots do, what the history of robots shown that the robots can do. So we have lots of robots in automotive, okay? I mean, that's where industrial robotics started. So we have robots loading. If you take a car process, we're all the way to the process. We start with the metal sheet that we are taking from stacks and feeding press lines. And the presses stamp the parts, and we transfer them, and then they move to the body shop. In the body shop, we put them together and we weld them with spot welding, laser welding, all kind of joining technologies. Then they go into the paint, okay? So you paint the body, and then you have a painted body. And then comes the marriage. So you have the powertrain and the body, and you put them together, and then you have kind of a car that you can start doing the final assembly and trim. So you put the dashboard, you put the seats, you put the wheels, and here you go, you got a car. So that's where most of the robots from us and from the industry in general were developing 80s and 90s. But then after 2000, really robotics expanded in many areas. You can talk about food and beverage for pick, pack, and palletize. Later into the century, big development in electronics. So we have lots of robots grinding and polishing mobile phones, assembling the electronics. And in the latest part, of course, we're developing logistics. And now, as we'll talk, we have robots in restaurants and robots in hospitals, and the story just begins.
So, Marc, this is so intriguing, because when you talk about these robots, a lot of people, when they think about robots, the first thing comes to mind is naturally a home robot, a robot that can help you at home. And we haven't really seen many of those. I mean, there are Roombas and so forth, but we haven't seen the kind of more general home robot that really does kind of everything, right? Yeah. But then even though we haven't seen them in our homes, you're saying the ABB robots are affecting our everyday lives all the time because they're building our cars, our electronics, and handling food. That's amazing.
Yeah, I mean, I would say more and more robots are behind. I mean, the development, the productivity development that is enabling higher wealth in the world. So if you think how much a car costs and the feature that the car has, how can you will be able to, in a sustainable way, get e-commerce happening, or how can you get fresh food prepared in a sustainable way and in a business sustainable way? Robotics is behind many of these developments. So the robotics is enabling every time more and more and more productivity gains that are translated in a number of benefits for society.
Mm-hmm. Now, one thing that I think a lot of people know about is Boston Dynamics, right? That's kind of the robotics company that gets a lot of eyeballs when they release videos, and I'm sure you've seen those videos.
Absolutely, it's amazing.
Yeah, but the ABB robots actually look very different, right? And there's many more of them for that matter, and they're working hard behind the scenes. But can you maybe describe the difference between, what does a Boston Dynamics robot look like, what people are used to, and then in contrast, what does a typical ABB robot look like?
Yeah, the industrial robots that are mostly used are in three different type of what we call kinematics. So how you assemble the different links that compose the mechanical part of the robot. The biggest part of robots in industrial use are what we call serial kinematic robots. So basically you have a number of joints and links that are mounted one on top of the other. So you have a first axis that rotates attached to the floor. On top of that, you mount another axis that pivots against the first axis, and normally up to 6 axes, and basically that has kind of the shape of an arm. So that's why we call it robotic arms. Then there are other variants, like some people call it the spider robots, which are parallel kinematic robots that move very fast, and they can look like a spider. And then you have the scatter robots, which yet another way of mounting the axis. So these are the typical configurations, and they are like this because one of the basic things on robots is reach and payload. I mean, that may sound like a boring thing, but when you go into industrial things, I mean, how much the robot can handle and how far it can reach is one of the basic things. So to optimize that is leading to these kinematic choices.
So to give some perspective here, right? I mean, the ABB arms are arms, the robots. They're not full bodies like a Boston Dynamics robot tends to be. But as you said, they have a spread of reach and strength. Can you say a little bit about how strong are the strongest ABB arms?
So that's super interesting because, I mean, we have robots like Yumi. By the way, Yumi is a dual arm robot. Many people have seen is the more, let's say, egg catching robot that we have because it has kind of a human torso and 2 arms. And that can lift as little as half a kilo. So it's a pretty low payload robot because it is designed to assemble chips into electronic boards and stuff like that. And then you go to the robots that are carrying these spot welding things. They carry some few hundred kilos. But then we have our larger robot, 8700, which is a Titan of 4 meters high, which can carry 1 ton. And can basically lift a car or lift a complete stack of pallets, stuff like that.
Wow. So that robot, if it can it lifts a car, no problem, is what you're saying, just on its own. Yeah,
absolutely. It's used as an elevator sometimes.
Wow, that's amazing. And then on the other end of the spectrum, you have the Yumi, but you also have these spider robots you just mentioned. And I'm also really intrigued by those because as I understand, they can go really, really fast. Can you say more about that?
Yeah, of course. I mean, these are the Delta robots, spider robots, parallel kinematic robots. The beauty of those robots is that, as I said, in the serial robots, every axis is mounted on the previous one. So you imagine the inertia that the first axis has to move all the rest. So this makes them with less acceleration. But if you want to go super fast, and these are the videos where we are picking cookies and putting them into the blisters or into the boxes, you have a robot where it is mounted in a way that every axis is independent, is parallel. So you have very low inertia, you can go very fast. And these robots are hitting rates where you can make half a second cycle time, okay? So this is, Can you imagine? You cannot even see it. So every second, it picks and places 2 parts.
Now, I'm imagining, I'm just trying to do the math in my head here, like 2 per second, like it's like 120 per minute, 7,200 per hour. Well, if anybody wants to eat cookies very fast, this robot can keep up, I guess.
Absolutely.
Yeah. Wow. Now, these robots, they're in so many places all over the world helping out. And you yourself actually have spent a lot of time, as I understand it, to go out and install these robots, design new installations, figure out what's the right robot, and so forth. You've been deploying robots all over the world. I'm curious about some stories there. What are some of the most, memorable robot installations you've done?
Well, there's really, really nice memories at the beginning of my career. When I graduated with engineering out of the university, I immediately joined ABB. And I'll tell you a story how, because it seemed like it was a destiny that I would end up here. But I went into ABB in July, and I was told, okay, here you have the flight tickets. Our robots are the orange ones. At that time, they were orange, by the way. And I spent the first 3 years in installations. So in places like Ford in Melbourne, in Australia, in Renault in Spain, in car factories. And then I was a long time in General Motors in Mexico, setting up the new factory in Silao. So, robotics was very different at the time, although we're talking 98. So, it's the infancy of robotics, but still in many of these factories, robots were, a low percentage. There was still a lot of manual things. So, I remember very well the startups, because some of these projects were summer shutdown. So while you were doing installation, there was no one in, and they would came in the 30th of August at 5 o'clock in the morning to start the shift at 6. And there was a lot of people around you, basically looking at you, sticking to the fencing, okay? And you had all the pressure to just push the button and feel like everything would start to move, the robots, the machines, and the parts starting to flow through the lines. And that was really exciting because it was a feeling of novelty. It was a feeling that of wow, this is something new. Over time, this feeling is a bit gone. There's still the emotion of starting up an industrial system with all the complexity and risk that it carries. But at those years was a lot of the novelty. Okay, in places like Iran, in places like in Turkey, it was some of the first robots we were installing those years. So people was really excited about it.
That does sound really, really fun. Now, as you said, you're standing there, you've got to press the button, it's got to get going. Because can you say a little bit maybe about what a car manufacturing line tends to look like, and then how you go about thinking through the robots that go into this?
Well, the first thing you must know about automotive industry is this a very advanced industry in terms of operational efficiency and optimization, okay? So if we can get the cars at the price that we get the car, it's because this industry has been decades improving quality system, improving optimizations. Everything is born then Six Sigma, Lean, all that comes out of automotive. So they're very good at that. And what that means is that the expectations in terms of reliability to begin with are very high. The contracts today are signed with 99% reliability commitments with strong penalties. So this means that the design of the robot and the system around it has to be extremely robust, extremely. The robots work 24/7. So I would say, again, this is not the most sexy thing, but there's a lot of science and engineering gone into making those robots so reliable that they would never fail. They can work 24/7 for 10 years with some planned maintenance, and they're doing the cycles. So that's a very big consideration when you think about industrial robotics. The second one is performance and through output. The payback of the robots in this industry is about the productivity gains, how much cars per hour you commit. So optimization of motion and optimization of speed is the other big thing. So the robots have to be reliable, and the robots have to be as fast and as accurate as possible. And that, again, has driven a lot of technology development in controls and so on and so forth. So, but this is really high demanding. That then, of course, when you go into other industries, you find other challenges, but at least these are already at the highest level, I would say.
Now, when you think about these things, it's kind of intriguing, right? Because you're saying there are big penalties. Like, what is it? what does that mean, big penalty? It sounds like if a robot stops for a few minutes, that's real trouble, right?
It is real trouble because, I mean, every second the line is a stop is less cars produced. And that has, of course, an economical impact. I mean, this is general. I mean, this is true for most of the manufacturers. But what happens in automotive, or has happened so far, is that they have, when it comes to the core processes, everything is one line. So you don't have parallel possibilities. If you stop the line, you stop the factory. That's always what they tell you. You're going to stop you don't want to stop the factory. And stopping the factory, of course, is not what you lose in that station, is the whole thing. So the typical contracts in automotive foresee indirect and consequential damages, meaning that everything that we're losing because of you need to pay us. That is the contractual setup. Luckily, things never end up or almost never end up that way because, of course, there is a collaborative approach. But this is really to set the framework or how serious things are in this industry.
So I got to imagine here you are, you effectively just graduated, right, from college. You, in July, right after graduation, you start working at ABB, you start traveling the world, installing these things, but you barely graduated, and people are telling you, if your installation comes to a stop, this is the penalty.
This happened. Well, I have multiple. The first one was in Renault, okay? It was a summer shutdown, and we were really late, I can tell you. I mean, when I look back, I mean, we were a bit brave by then. In general, things were a bit less professional. I mean, the robotics industry, how you were doing projects, it was kind of developing. So we were very tight. And the Renault plant manager came down to the shop floor, okay? And he said, he came, it was a 2 meters tall guy, okay, dressed in a suit. I mean, you're really fucked up. Sorry for the language, but I mean, he told me that. And I was looking up to him and said, with my teach pen on my hand, I'll do my best, man. But I mean, I know what's the implication. So that guy today, Jose Vicente de los Mozos, is the head of Renault operations. So he was there. Now he oversees the whole Renault factories in the world. Then later I went to General Motors in Mexico, and the project manager was a very fantastic person, Rick Carmona, coming from GM in North America. And we had a big problem because it was a press shop. So there was several press lines, and they stopped the largest one for us to put the robots, and they sent the dies to a supplier, to a tier one. So while we were doing the job, the tier one was stamping the parts to be assembled. But one day they got a call from the tier one. Our press is about to break. And there was no spare press in Mexico. The parts were so big, it was the Suburban truck. There was no other press in Mexico that could do the job. So then they called me at the hotel, 4 o'clock in the morning. You come here now. I drove to GM, said, you know, we don't have a press. So you need to get that running. I had 4 weeks of window. They asked me to do it in 4 days. Okay. So I said, that's impossible. So then he took the phone. He called Detroit. Okay, Mark, we're going to fly the parts from Detroit, and you're going to pay for that. So I said, okay, look, I was 25, and I said, can I call my boss? It's like the lawyer's call. So I said, and then I couldn't call Spain because it was still, they were not in. So, I mean, and in the end, we, again, through collaboration, because in reality, then everyone has to work with the same objectives. We had a hybrid. So we put the robots, but we were operating with a button in manual, okay, in one station, and then you had people on the other one. So day and night, we were putting the robots one by one. But you need to imagine the picture. Every single part stamped at the body side that was coming out of the line, the people was running to the body shop. They would not even put it in containers. Can you imagine the stress? Mm-hmm. They were running to bring the part to the welding line, where normally you would put in a container, it would be in a warehouse, and in 24 hours, normally they would pick it. It was just real time. That was really, really real time, or just-in-time production for 3 weeks till we managed to get stabilized. But that was tough.
Yeah, that sounds like quite the adventure. You were working there for just a couple of years, being put in charge of so many responsibilities. Yeah. Stakes are high in manufacturing every single time, it seems.
It's a lot of money, as you say, for a young engineer. Any of us that goes into manufacturing robotics, all of us, we are facing that. And it's exciting because it's a great development. It's not only the technology. Of course, when you program the robots, the PLCs, the SCADAs, you wire up the relay, you learn a lot of things. But the more thing is you learn about how manufacturing works, and you learn about the people in tough situations, and how working in teams is really the only solution. And that is a learning that really goes so deep into your heart in those stressful situations that you take it forever on the rest of your career.
Mm-hmm. Now, talking about taking things to heart and careers, out of college, you went straight to ABB. Was there anything before that maybe could have hinted that you might end up in robotics?
Yeah, as I told you, I mean, it was when I was in high school. I mean, a cousin of my mother was working in Nissan as a the head of the die section, and also my uncle owned a die shop. Okay, so I always was brought up in between presses and dies. And one day I asked the cousin of mine, "Hey, could you sneak me into Nissan? I want to see a car factory because I heard there are robots." I said, "Yes, we do have robots." And I went there, and I imagined the sound of the boom, boom, and everything shaking as I was approaching, and I saw those big machines. And then I start seeing the little robots compared to the machines, although they're big, moving the parts, and say, "Hey, here they are." And that day I knew I wanted to do that. Okay. And then I chose to do robotics in university. And then I knew ABB was there. So I applied, and they chose me. So I've only done one interview in my life.
Wow. One interview and success, and ready to go. That's amazing. Yeah. Now, actually, something a lot of people might not know. I think a lot of people know ABB, the story you mentioned, it's partially Swedish, partially Swiss in our origins, but actually you're based in Spain. Is that right? Can you say a bit about the Spain office?
Yeah, I mean, ABB is truly global. So we're really, really strong and in all countries. Our office in Spain, of course, it roots back to the start of automotive. So when ASEA started the first robot sold was in 1976. And the first robot in Spain was sold in 1979. So Spain is the second producer of cars in Europe. That's probably not much known, but I mean, Germany is the first one and Spain is the second. Lots of car factories here. So it was the same in terms of robot adoption. So we started to work with Citroën, the French brand, now part of Stellantis. And our history was in the 80s very much in automotive OEMs, because also the sub-suppliers, the tier one, were very much developing. And what happened there is that we were specializing in one application, in that case in metal forming and stamping, and we were given the responsibility to develop that globally. So because you cannot have all these application competence in every country, because it's a lot of knowledge to build up welding or painting or press automation. And that's how ABB is still organized today. We have our local units who, let's say, cover the countries, support our customers. But when it comes to certain specialized domain where you want to provide a solution, we are doing that out of certain hubs of engineering. And in Spain now, today, it's a team of 300 people, roughly 100 millions with a local business and a few of these, what we call them global solution centers, which have the responsibility. Press automation is still there, where I was brought up many years. But now we have, for example, a center for 3D vision for metrology. So cameras mounted on robots that do inspect parts and so on, and some more stuff. So, but for example, our biggest team is in China. In China, we have only 2,000 people working in robotics, and we have the full value chain. We have factory, R&D, products, engineering. So we are really, really spread.
So, Marc, one thing I noticed is when I look at your LinkedIn, yes, you started out of college, but I look at your LinkedIn, you're at ABB, you did your one job interview ever, you got the job. But then within ABB, maybe they're not interviews, but you're like going up in some sense, the corporate ranks very quickly, year after year after year after year. And a few years ago, you're leading as I recall, a $300 million team. That's where your team is generated.
Yes.
And you have hundreds of people working with you, maybe even more. And then you decide it's time to restart from scratch. Tell me more about that.
Yeah, absolutely. I mean, we had been growing this It's a big business in Spain, 300, doubling the business in 4 years, very, very successful. And that was a broad business. I was managing motors, drive, power electronics, and robotics in Spain, which I never left robotics. But then I was given, I got a call from Zurich, from the global manager of robotics at the time. And he said, Mark, with your feedback and everyone's feedback, we know that we need to take the next step in robotics. If ABB is to lead the next decade of robotics, we need to start now. And that was 2017 when we had this conversation. We need to start working towards next era of robotics, which we all think is going to be different and bigger. And that's what in robotics jargon is called service robotics. As we know, it's everything beyond a factory wall. It's called service robotics in a way. So they proposed me to leave my job and take on a internal startup or corporate startup, which had at that time 15 people. An incubator for logistics to try to work with Amazon and this DHL and so on in UK. With the prospect also to invest in healthcare, which today we have now our center in Houston and another one in Shanghai, and later on take on retail, restaurants, and all this. And I said yes, okay? And I said yes because I'm passionate about robotics and about business and about learning. And I thought that I could learn a lot, that I could help coin the next era of robotics, try to drive it in the right direction from a business perspective, but from a robotics perspective as well. And that would be fun. So I took in the challenge, and now, of course, we've been 4 years in that journey.
I think that's pretty amazing to go from a many 100-person team to a 15-person team that's going to go into a completely new domain, service robotics. Personally, I'm very excited about service robotics, of course. As you know, I think it's effectively where AI starts becoming really important for robotics, because the environments are less structured. And so it's a really interesting space to be in. But it's also a new space, and it's kind of, your revenues are probably not matched up with the revenues of your previous team just yet.
They are exceeding it already.
Oh, wow. That's amazing. Now, you talk service robotics, you hit upon a few things, and I'd love to talk about all of them separately. So you mentioned, logistics. You mentioned medical. You mentioned food. I'd love to start with logistics, because that's one where we intersect quite a bit, of course, in our partnership between Coverent and ABB. So, can you say a little more? What got you attracted to logistics? Why is that such an important thing?
First is that, it's so close to us as consumers, as person, we all buy online. We're really living this digital revolution through the mobiles. We have everything at our fingertip. So I said from that standpoint, this is big. This is one of the biggest things that, at least in my life, I will go through. So that must have an impact in robotics as well, proportionally. Because if you start going back the value chain, just when you get something, how it was delivered, the order was prepared, how it was manufactured, how it was customized, blah, blah, blah. You can just feel the impact. So that's what attracted me. But the biggest learning that we had the first 2 years in logistics, when we were just focusing on distribution centers or fulfillment centers for e-commerce, and that's why we reshaped our business line in ABB, is that because of this, the value chain of manufacturing, distribution, and retailing has totally changed forever, and it's become one single thing, okay? If you want to understand and win in this business of selling something to consumers, you need to understand the whole thing, because everything is interconnected. Today, a brand like, Procter & Gamble can sell directly to a consumer through a web, and they can bypass the 3PL and the retailer that was their only channel to market. Can you imagine the disruption? The same way around, if you're a brick and mortar and you have to compete with e-commerce, you need to figure out how you leverage your assets and your strengths. So this is a revolution. It's a holistic thing. No one knows really what the steady state will be, because no one knows. What percentage of drive-through, what percentage of in-store, what percentage of home delivery. And that will be different through geographies, by the way. But it's a very dynamic thing. Now, the thing is that all companies involved on this, they cannot stay idle. They need to invest, and they need to take risk, and they need to bet on certain models, on certain things. So this is making things, on one hand, very exciting from speed, investment, and so on, but also very risky. And we're trying to balance out there how we help customers make sure they can really achieve both. I mean, be successful managing the risk and the investment.
Now, let's think about this in terms of a concrete example. Let's say you deploy a robot in a logistics center, a warehouse. Can you say a little bit about what that robot might be doing?
Yeah, if you go from inbound to outbound, so the first thing you can imagine, trucks come in, they need to be unloaded, okay? Typically, this is done manually still today, although you've seen like Boston Dynamics showing some robots that will do that in the future, will also do that in the future. But then the boxes, typically, they need to be depalletized and put away. So you have robots doing depalletizing and putting things away in a storage. Then as the order list come, you need to retrieve that from store, okay, and need to break it down. And then if it's a fulfillment center, you need to build up a mixed pallet again to fulfill an order for a store. Or if it's an e-commerce, then we need to do item picking, which is what we do together with you in Covariant. So then later on, you also need to sort the orders. If it's e-commerce, so you have the order, but you need to put it into a place that it's going to send it to one city or another city. This is called sortation. So robots in palletizing, depalletizing, order picking, sortation, these are the core things. Some of them do not require AI, but the more massive and impactful ones do require AI.
We are dropping new interviews every week, so subscribe to The Robot Brains on whichever platform you listen to your podcasts. When you think about AI making its way into robotics, robotic automation specifically, right? It's got to be a big change for ABB, right? Because you're used to deterministic systems and where reliability is measured in a very kind of specific way that you're used to. Now you come into AI and, these are systems that use machine learning to make decisions. So, how did you kind of change thinking about things, and how do you, go about reliability in those settings?
This is really one of the big challenges. This is one of the big challenges that, the whole industry will need to learn together and get to some new standards. Because as you said, on one thing, the system, because there are two things here. How do you assess performance, and how do you model then the business case? Because, when things are deterministic, everything is easy. You compare Excel to Excel, the performance, and you make the numbers because you're going to get this performance and you're going to get this payback. When things are a bit more fluid, how you do that? So we thought a lot about it when we started. And, the first thing we said is, how do you can really compare performance? And the only way to do that is to have a pattern. So we created the speaking challenge where we put together a number of use cases that every AI would have to compete against the same pattern. So that's the only way we could compare. Now, this is something that we have well established. By the way, we're thinking to utilize that for other AI-driven things like 3D navigation of vehicles. How you would compare a 3D navigation is better than another? You need to create some test. So, but now the challenge is that as we are having the first deployments together is with our customers, once again, how do we measure our commitment? Well, they are used to be given, okay, we're going to do so many picks per minute, and that's it. Hey, things are not, we're going to do some picks per minute. There is a universe of SKUs that we know will work, but you and I know that you can get anything different tomorrow. So how are we going to deal with that? Once again, we're trying to create a framework which we can commit to and that we can be measured upon, that the customers can effectively measure us against, and we can have a commitment. But the tricky thing is that they know that in no case, no one will be able to secure them the complete picture, because the picture is dynamic on their end and the picture is dynamic on our end as we learn. So this is really the last step, that the end users need to understand their CapEx investment in a different way when it is an AI investment. And also looking at CapEx differently, and probably looking more into an OpEx thing where you are continually evolving, and here's where different subscription model will kick in. But this is a journey. People is not used to that because simply machines and automation did not work like that without AI.
Absolutely. And so one thing I remember from the competition that you organized was, a lot of our listeners work in machine learning. This will ring home to them, but not everybody. This notion of a test set, right? You actually sent us, somebody from ABB came by with many bins of objects, full of objects. The robot was supposed to pick them one at a time, not leaving anything behind, never double picking, and so forth. But I thought the really interesting thing was that for half of the bins, you didn't tell us ahead of time what's going to be in it. And that's in machine learning a test set. It's something you cannot prepare for directly. You hope by preparing on other things, it'll generalize and still work. And it did in our case. But it's a very interesting concept, this kind of being tested on things that are not explicitly announced, which reflects the real world where things are always changing. And so I thought that was really, really interesting. And I'm curious if there's more things in that direction you've been thinking about and how you evaluate things.
Yeah, absolutely. Absolutely. In general, any type of AI, deep learning or deep reinforced learning, you need to, there's some things you're more sure you can do if you've trained and you've tested. But the reality is that if we use machine learning whatsoever, it's because we want to cope with some dynamic environment and structured environment. Otherwise, we will go back to some more traditional methods. So that is the need per se. So for item picking, we did it this way. But as I'm telling you right now, think about another use case, which is free navigation. Okay. Mm-hmm. So if an AGV has to move around a warehouse or a factory, yes, you can do some tests and you can test, do you identify a pallet? Do you identify a column? Do you identify a person? But in reality, you're not supposed to see a dog in a factory. But what happens if a dog crosses by? So the same principles of known pattern and unknown, I think, will be very important to check the robustness of any industrial application, because ultimately the purpose of applying AI is to manage this type of situation.
I couldn't agree more. And it's part of what makes AI so exciting, right? This notion that it's capable of doing things that you didn't directly program into it, or at least it doesn't feel like you programmed it directly into it, yet it somehow still can perform the task in this new situation.
This is going to change the management of the company, because when a manager manages their coworkers, of course it's the same thing. The person, the employee is supposed to be trained on something, but ultimately you don't know their exact performance, how it's going to be. So now AI robotics is just the tip of the iceberg. But imagine when factories will be 90% of the robots will work with AI, and you add on all these, let's say, percentages of different behaviors, and you add the whole thing, it's going to be a total management system. Because one robot is one thing, but when you're going to have hundreds of robots, that's going to be a total different thing.
Yeah, and that's going to happen, right? It seems the sure path forward.
Absolutely, in the short term.
Now, Marc, when you think about these problems and how to deliver something to a new warehouse, let's say, can you say a little bit about how do you think about the whole concept? Like how do you, when you get asked to, deliver maybe an order picking station or a palletizing, depalletizing station, what's the process, and how do you go from just that beginning to delivering something?
Yeah, the first thing is really, for everyone's sake, to really find out if there's a business case behind, because it is true there's a lot of hype of robotics. Many people just are told by the board, hey, we need to put robots in. But the reality is also that robots make sense when they make sense. Okay, so there are certain parameters where that can be very various, make sense. So the first thing is really sit down, before solving the problem with the robot, what's your problem? Okay. Oh, we do this. Why you want to put the robot? No, it's ergonomy. People are breaking their backs, or I don't have people, or there's a quality issue because the boxes are broken. All right. Then it makes sense. How many you have? How many shifts you work? And then because that is really setting the trust that the time spent for both will be good. And then we go into a process analysis. Okay, what are the number of SKUs? What are the number of order lines? What are the through output? And then we define the material flow, we define the layout, and we dimension the stations. Do we need 2 robot stations, 3 robot stations? And as you go more in detail, then we go, okay, what type of SKUs? How is the end effector? How do you manage also exceptions? Because we also are very true. Today's technology has to work, requires to handle exceptions, okay? Because the variety of things that can happen in a warehouse, for more that AI is now super advanced, it cannot cope with them. Sometimes it's not an AI limitation, it's a mechatronic limitation, like the end effector and so on. So this is called the non-happy flows, okay? So what happens if this gets stuck, what happens if we cannot pick this also has to be taken care of. And we end up then with the test plan and the project plan.
And now you go out, you have the plan, and you deploy, and then you measure. What happens next?
Well, with AI now, what we're doing together, of course, is that there is a training phase. For more that the brain is trained, it's always a benefit for all. Okay, if we can get a sample of your particular SKUs, we train the system in advance. This has proved to be a good investment. Now, that over time probably won't be needed for certain segments. I mean, we're doing a lot in fashion right now. So we've seen together lots of poly bags with trousers and T-shirts and belts and so on. It's still good to do it. At certain point in time, we won't need it anymore, okay? But then next day, we might be doing something in pharmaceutical, and that's probably about the cuboid boxes. And yeah, maybe it's good to train for some time. At some point in time, any cuboid we can pick, the brain will know it. But I mean, the list is inimaginable. And if you end up in an Amazon type of center where the SKUs are 20 millions, then you really need to be in a frame. Okay, once that is done, then we need to do the test. And the test we are trying to do, as I said, against a pattern, okay? We said this pattern we can commit to, we test the pattern, and then we go into real life, which is basically anything. And then the anything, there's this level of uncertainty that everyone needs to understand is going to go with it, okay? But the learning is that if the commitment gets to a certain minimum, then the rest is a plus. And that's luckily the good feedback we're achieving right now.
Yeah, and that's been really exciting, of course, for both of us to see that play out, or play out more, work on it to make it happen than just see it play out.
Yeah.
Now, I'm curious, as you think about, these robots in warehouses, do you see a natural expansion from there to other domains?
Yes. I'll put you an example. Now in China, we have commissioned with Haidi Lao, which is a very large restaurant company, robotic restaurant for hot pot. Okay, hot pot. If you have eaten this Chinese food, is basically you order different plates with raw meat, raw vegetables, and you have a boiling pot in your table, and you just cook it. Mm-hmm. So this is, if you think about it, it's a logistic process, because what the robots do is that the portions of the dishes, so a dish with certain meat, certain quantity of mushrooms, that gets to the restaurant, and it needs to be stored in a cold room. And then when people is ordering, in this case already through an iPad, to pick an order means that you need to retrieve certain dishes and prepare an order. So it's really an order picking. So the reality is that we've implemented those robots that are doing exactly this, and we have reutilized the software for storage and retrieval that we use on our robotic systems in warehouse. It's exactly the same.
Wow.
Okay.
So are you saying that, if I were to fly to China and I go to the right place, I wonder where it is, I can eat at a restaurant where ABB robots are doing logistics behind the scene?
Yes, that's a restaurant in Beijing, and we hope to do many more. And there's also noodle restaurants in Zhengzhou, where this is absolutely unmanned restaurant. There are 2 robots of us which are preparing the noodles that you want.
Wow. So you order something, and then that order, the robot kicks into action.
Yeah, that is fantastic, because imagine you have your app, and there are some preset recipes, but you can make your own secret recipe, okay? With a little bit of this spice, with these minutes of boiling the noodles, with this quantity of vinegar, and that's your recipe. And the robots will execute it consistently over time, no matter in which restaurant of the world you are. But it's not only that, because it's even smarter, because, of course, you are sharing that data with the customer, and then they apply AI, okay, and they look at your tastes, and they can generate individualized campaigns. So you get a promotion on your phone, which is only for you, because you like this Sichuan sauce, you like this vinegar. Hey, we're suggesting you this recipe. and so on. So, I mean, robots are enablers for truly digital business. That is an example in restaurants, but there are many others where robots, it's not only the physical thing they carry that they do, but they bring digitalization to the whole process.
You said that these robots are in China. Is there any reason that you think they're in China? Do you think that's the place they're going to largely be first, or is it just coincidence and there will be many in other places very soon?
No, I mean, highest robot density, as you know, is in, if we talk density, it's Korea, then it's Singapore and Japan. So adoption of robotics in Asia is much faster and culturally different than in Europe and in US. Automation is not seen ever as a threat, but as a booster in many aspects. And that's why adoption of robotics also in China, which is still a low-cost country. China is the largest market in robotics already. It's 40% of the total global sales of robots going to China, and that's expected to continue in the coming year.
Wow, that's so interesting. All right, and glad to have you back after a short break, Marc.
Yeah, kids coming back home need to find a place.
Well, I'm glad you found a new spot, and we can continue our conversation. So the thing that's been on my mind since the beginning of our conversation here is your reference to healthcare, robots in a medical center in Texas. I mean, who doesn't want better healthcare? I think everybody. So I'm very curious, what's going on there?
Wow, I'm super excited about too. I mean, for more that I love painting cars and that stuff. I mean, when I thought that robotics could really help people have better healthcare, that's super exciting. So we started. I mean, first thing, why we landed in Houston, it was not coincidence. We were really screening the world to look at the healthcare hubs in London, Oxford, Shanghai, Singapore, many great places, of course, that are there. But what we found in Houston is really unique. I mean, the concentration of hospitals, academias, and the umbrella of the Texas Medical Center makes it a unique place. So then we started to really understand what are the challenges in this industry. So we found out that it's really a tsunami coming in. People doesn't talk much about it, but especially in US, for example, is a big thing. So we have shortage of labor, shortage of talent. The processes likely are becoming more complex because we have lots of new treatments, but mostly personalized drugs. So the complexity is becoming very big. And then also we have a financial problem because population aging is putting a big strain. Because after 65, every year you live, you go 3 times more to the hospital every year. That's an impressive exponential. Wow. So if you put all that together, I can tell you the system is broken. It's unsustainable just 5 years from now. So what do we want to do? Where do we think we can help? I mean, many people have seen and talks about the surgical robots, okay? We are not in that space, although it's fantastic, but this is really a medical thing. I mean, the robots are amplifying the surgeon in this case. It's not about automation, okay? So we come from automation glasses, from industrial glasses into these facilities to really try to understand how we can optimize and alleviate these operational challenges, the lack of skilled people, so we can free up time for nurses, doctors to do what they are best. How do we reformulate the processes so they are more optimized? Because when you automate with robot glasses, it's not only about what you do, but you look around and you normally change the process to make it more efficient. So with that, we found out that there are 2 immediate areas where we're acting. And one is, of course, the laboratories, okay? In the laboratories, you have repetitive tasks, non-added value tasks performed by highly scarce and qualified people. And you don't want that. But it's not only that. It's so much everything around the patient that the process have not been optimized. I'll put you an example. The first project we've done in Houston is a very simple one at the largest pediatric hospital, Texas Children. The robot is loading and unloading blood samples from a centrifuge, which is the first pre-analytical process. You spin the blood to separate serum from plasma, and then you go into sugar analysis or different type of analysis. So the current situation was that they had 12 manual machines spread across the lab. And we said, okay, machine tending is an easy application from robots. You have a rack in somewhere, you place it in the same place, you can pick the tubes, load it, and spin it. And we did that. So now we have a Yumi robot in the hospital doing this, which is fantastic on its own. But the most important thing is that we analyze the process, and now instead of having 12 machines, we have one with a robot. Because the fact that you put the robot is also driving along the let's say industrial process thinking into hospitals. So with that, we can do these things. But this is a tiny example. Now we are doing much more advanced things. For example, robots automating biotech process. We are helping accelerate the COVID testing in many places. So we have robots testing COVID in Singapore. In Singapore, 75% of the patients inbound to Singapore are tested by ABB robots. The same in Taiwan. And now in US, and this is coming soon, our robots will be helping accelerate testing of the effectiveness of the vaccine. So now we have vaccination, but we have the threat of new variants and how that goes. So the robots will help also accelerate that. The robots are helping to develop cancer treatments faster because we can speed up R&D dramatically. So there's a lot in laboratory automation, Peter.
So Marc, I want to double click on that a little bit. When you say in Korea, you said Singapore, maybe some other places, 75% of the COVID testing is done with robots.
Yes.
What should I envision? What does it mean for a robot to do such a test? What does it do?
Well, I mean, there are some videos in YouTube. The robots basically, I mean, you have the samples that come in tubes. So the robots are picking the tubes, are opening them, are extracting the sample, are putting the sample into the analyzers, or into some plates that hold a number of samples that go into the analyzer. Then we're unloading the analyzers, we're taking the sample, putting them into the right place, scanning the barcode, registering it, and sorting them to the next step of the process. So the robots are basically making the linkage of all the manual and non-manual processes, making that faster and robust through robots.
That's so interesting, because I think when most people think about COVID tests, they would think about, oh, somebody's stuffing something up my nose kind of thing. But so that's the robot is not like in your face. The robot is behind the scenes doing all the laboratory work to actually return the result of the test.
Exactly. That's why you can get the result in less than 24 hours and cope with this big amount of testing.
Got it. And similarly for, you said, testing the effectiveness of the different of the vaccine against different strains.
Yes.
Can you elaborate a bit on what should we envision when thinking about that?
Yeah. Once again, I mean, you have now people being vaccinated, and there is a concern how effective over time the vaccines will be. But there's also the threat about the new variants. So the medical community and the pharmaceutical community are developing ways to check that through some, design viruses. But that means that you need to put some blood sample against those viruses and see what the effect is. So that again is a process that is of course performed manual in a lab when in the development phase. But if you really want to make it effective, you need to scale that up. And the way to scale that up is through automation. So the flexibility that the robots have provided to have enabled these people. So I'll put you an example. Manually, they were doing 20 tests per day. Now they're going to do 1,200 tests per day.
Wow, that's amazing. Now, when you think about the healthcare robots that are doing COVID testing, checking the effectiveness of the vaccine, but also directly helping in the Texas Medical Center, I got to imagine what you just told us about are just examples of how it's getting started. What's your vision for this? Where do you see this end up?
We really share a vision about how we can impact hospitals. The first thing is really an end-to-end optimization of the value chain. If you look at the hospital, besides the most important thing, which is the direct care of the people and the treatment, the rest behind that is a macro fulfillment center. And some people will kill me to make it such cold. But in the end, when the doctors and the nurses determine that some treatment has to be given to the patient, what's behind is a fulfillment center. So I mean, you have a warehouse with the incoming drugs. You have some need to be refrigerated, some other need to be compounded and prepared and have a short lifetime and so on. And then you need to make that get to the patient through the lab. So it's a complete loop of getting data through the labs, making the diagnosis, defining the treatment and making the treatment go to the patient. So all that chain is really, if you would come there with, again, industrial glasses, that process is broken. It's because everything has been designed around the patient, again, for the good reason, and it should stay like that. But there are so many things that can be optimized. Now, again, the robots physically will be automating the warehouses. The robots are already today preparing some drugs in the hospital. That is called pharmaceutical compounding, in vitro compounding. But the robots, mobile robots, are delivering already the medicines or the meals and get back the line into the laundry. So you are automating all the material flow inside the hospital. So that's a big thing where robots will help, I would say, first in the short term. Going forward, the robots will get also into medical assistance. So, for example, robots in rehabilitation. There's going to be a shortage of physiotherapists, people that, because also these things are dynamic over time. If you have a disease that is, getting worse, the physiotherapist and your pain level, for example, increases every day. That physiotherapist needs to apply a different force, and it's a different patient is a different kinematics and a different dynamics, if you allow me to use these words. But in the end, what you need from the physiotherapist is their knowledge to decide what is the motion you need to do. But once it's decided, for that day, a robot could take over. So rehabilitation is a big thing that will happen. Then assistant to surgeons, assistants to doctors, robots bringing the tools, robots checking some of the things surrounding the key things. That will be the next step after we settle the operational part.
That's amazing, Marc. When I think about this, I mean, first of all, the analogy you made of, how much of what happens in a hospital is so similar to what's happening in a warehouse. So much flow of materials, and we kind of know how to automate a lot of the warehouse flows. So it's an amazing insight to bring that to bear there. I am really curious about that next step also, though, which is, let's say a robot actually helps a doctor. Like, I could imagine some things robots are, maybe not as good at, but other things robots are really good at. Like, robots have extremely steady hands, if we can call it that. They're not really hands, but a robot can keep still really, really well. Do you have any thoughts on kind of complementarity of kind of the strengths you'd imagine robots would bring to these kind of things?
As I said, surgical robots are a reality, and and they're going to grow a lot. There's the big player, the famous Da Vinci robot. There are many newcomers that are coming to the market. Why is that? Because of what you said. The biggest knowledge of a surgeon is about the anatomy and what it needs to do. But in the past also was to be how steady his or her hand was. But this is something that now a robot can do better. So the surgeons are really concentrating in some specific surgeries, of course, not all of them, in really bringing the knowledge of what has to be done and not having to worry about if they have a bad day with their hand or not. So that is amazing. But that is very specific. What robots are generally good at, as you say, repetitive motion, consistent motion, okay? So anything in these environments that requires, repetitive material handling, machine tending, handling of goods, that is something robots could do. Now, the special thing, though, is that part of the hospitals, we can still make them, structured environments. Some other parts will never make them structure. And then once again, where we're going to need AI, because maybe in a lab, you can design the workbench so you're locating the things always in the same place. But if you're going to be in a patient room, you cannot tell the family you need to leave the pills here and there. The robot will need to see them and grasp them. Okay, so if we really look at the whole picture of robots supporting end-to-end, AI also will play an important role in certain applications.
Looks like we have some exciting opportunities ahead there.
the list doesn't finish, Peter.
So Marc, you've been in robotics for a while, 20 plus years, really exciting. But that's not where robotics started, of course. Robotics is older than 20 years. Can you give us a little bit about the history of robotics?
Yeah, of course. I mean, maybe the first thing is where the robot word come from. The robot word comes from the Czech language because it was used, and the concept of a robot as a machine that performs some task, that does some work, was first portrayed in a show, in a theater, a script in Czech Republic, beginning of the 20th century, and it was called Universal Robots at Work. And actually, robot means in Czech kind of work. Okay, so there was people already dressed up in metallic kind of silver clothes, being instructed to perform some work. So, but the definition of robot from, if you want, ISO is a machine that is reprogrammable and repurposable. And these programmable machines that can do different tasks, they started already quite some time ago. And the first were not obviously microprocessor driven and electrical. They were hydraulic robots driven by electrovalves. But really the modern robots as we know them, they started in the 70s, where computer power was becoming more compact and powerful. You could imagine to have 6 motors controlled by a small microprocessor. And that basically starts in the 70s. And basically since then, of course, the power of robotics has gone hand in hand with computer power. And of course, then came that enabled vision, and later on cloud and AI and so on. But that's a little bit where the history comes from.
That's so interesting. Now, when you say in the 70s is when the first kind of modern era electrical robots come about, can you say a little bit, what were those robots doing? Were they actually doing something, or were they just in laboratories?
The first robot that ABB produced was grinding pipes. You know, there was a turning stone, and they were putting the pipes and grinding them, polishing them, basically. So they were the first robots were doing material handling. They were picking objects and basically loading machines, because that's pretty simple. But bear in mind that today, out of the old robots that are sold in industry, still 55% are doing either material handling or machine tending, picking one object, putting it somewhere else, taking it out. That's what the robots do still today, because that's something, I mean, where you didn't need a lot of additional, let's say, intelligence to automate the process. And then second to that, then came the big boom of spot welding. So in the 70s, you started like that, and then automotive saw that. They took the robots and basically they kidnapped them for 20 years. And all the efforts in the robotics industry was put into spot welding, into bone and wipe, optimizing the robots in terms of payload, speed, cost reduction, performance increase to weld and weld and weld. So for the most part of 80s and then 90s, it was kind of a 50-50 split in between material handling robots and spot welding robots. And still other applications were rather small. That is not the picture today. However, material handling, machine tending still accounts for the half.
Now, Marc, when I think back in parallel to AI history, to your robotics history there, I mean, back then, AI wasn't that capable compared to today, obviously. So what should we think about? Was there any kind of AI in those robots, or how I mean, were they using cameras?
No. Of course, one of the things that defines robots is that they have input and outputs. And those days, you barely had some digital inputs and outputs from limit switches, proxy sensors, stuff like that. You may have for some process, some analog sensor of temperature and pressure. So the robot could have some kind of PID loop in some more of an analog process. But very, very simple. Many of those installations would not even have a PLC. So you can imagine the number of IOs, the complexity of the logic. They were basically starting with the really, really dull and dirty things that were not safe, and also the things that humans would not get the quality right. And you can imagine a welding shop with all the fumes and the sparks. That was really, really a very tough place, as well as paint shops and so on. So that's what really drove it at the beginning. But definitely not AI. Everything had to be built around the limitations of the robot, and that was driven also the type of applications robots were applied to.
Got it. Now, so Marc, I love the stories on robots starting to make their way out of factories and into warehouses, restaurants, medical centers. It's just fascinating what's becoming possible. But as I understand it, the stories you told us are about things that are happening today. These things are happening today. Now, I'm really curious about what you think is going to happen in the next 5, 10, 20 years. What do you foresee robots will be doing?
Yeah. Well, I think robots will help in many more segments and places, basically powered by a number of technologies that are running exponential. Of course, AI and visual perception is one of them. Take, for example, agriculture. There's, like I said, in healthcare, there's a tremendous shortage at the corner. In agriculture is the same. We're truly risking not to have food. In UK, 1 out of 3 farmers is above 65 years old. Can you imagine that? So no farmers in the horizon. So there's something urgently needed to do about. But I mean, the challenge to go outdoors and pick apples from a tree, it requires mobility, it requires vision, it requires grasping, it requires connectivity. I think the building blocks are there, and there's a number of startups really doing great jobs there. So I can foresee that in 5 years, the next big thing is going to be robots in agriculture, weeding, seeding, and harvesting, also enabling urban farming, for example. All in all, to gain productivity, save water, have better food at better prices. The things that have happened in automotive may happen also in this food revolution. Still in food, I mean, there's huge things in food processing that are, and COVID highlighted them, that are very, very tough and risky in butcheries and so on, cutting process, deboning process, that also it requires a lot of, it's a very complex process that will probably also be enabled. And if you go to the other extreme, when you're thinking about more service robots really, now we see Spot from Boston Dynamics again, helping to work around civil works, construction to inspect, for example, robots doing inspection, robots doing surveillance, robots, I mean, mobile manipulators like the mobile Yumi, we showcase a concept at Houston, at the medical center, will be around us, okay? Guiding us in places, helping us find our way in a museum. I mean, I can foresee that robots will finally come into unstructured environments. And this will happen through the visual perception part, through more advanced locomotion and mobility. All that put together will enable a lot of new opportunities for robots to support.
I personally couldn't agree more, Marc. I think the whole AI wave that's happening right now is really going to open up a lot of these opportunities that used to be just impractical to be accessible to robots. But now all of a sudden, if they can understand what's around them, react to it. One big one that's also on my mind, and I'm curious about your thoughts, is recycling.
Yeah, but this is already happening in US, for example. There's a great company called NRT, National Recycling Technologies. They are sorting trash with our robots, with our spider robots in this case, because it has to be very fast. And they're not the only ones. I mean, there are many companies now that are sorting trash, different type, separating plastic, separating ferrous materials using robots. So that is a reality. But I'll tell you even more, because this is at the beginning. I think that recycling is the future mining. In the future, mining will be about going into waste and recycling things, because some things basically we will run out unless we go to Mars, and robots are already there before us, by the way. So I think robots will play a huge role in the future commodity market, because we'll go from mines to recycling.
That's so interesting. Thinking of what currently we consider our waste dumps is going to be our future mines to dig out all the valuables that we're just failing to recycle today. You mentioned Mars. Any thoughts on putting an ABB robot on Mars?
Well, yes. I mean, of course. I mean, our Yumi robot is super light, and it has already caught the attention of some of the space agencies. I cannot disclose more. But definitely, and some of our team members have worked in, for example, robotic arms in the International Space Station. Jordi Artigas, that is working very close with you, he was working in DLR in Germany. So robots, of course, are today already a very important part of space missions. And I think that they will be fundamental for mankind to really conquer Moon, conquer Mars, because in those places, the things that in on Earth are meaningful, there they will be amplified, because the risk and the conditions will be much more difficult. So it will make probably a lot of sense to have robots risking their gearboxes instead of us doing a number of things.
Yeah, that makes a lot of sense to me. I mean, just recently Elon Musk said we might not make it back alive, anybody who goes to Mars. So, I mean, it seems nice to be able to send some robots for now.
Yeah,
absolutely. So, Marc, this has been an absolutely wonderful conversation. Learned so much. Thank you so much for making the time.
No, thanks to you, Peter. It's also exciting to talk with you as always. I really follow your podcast. I think they're very pedagogic and illustrative for everyone that really wants to learn about AI and the future of technology.
Well, and we just wrapped one more today. Hope people will enjoy it.
Thanks a lot.
Thanks again, Marc.